In this next rational function, we have f of x equals x minus 1 over the quantity x squared minus 3x minus 4. We're going to go ahead and factor that denominator. So we'll write this as x minus 1 over x minus 4 times x plus 1. Note that there are no factors that are common to the numerator and the denominator. So setting the denominator equal to 0 will actually produce two different vertical asymptotes. So we have x equals 4 as one vertical asymptote and x equals negative 1 as another. I'm going to go ahead and add them to the graph as dashed green lines. So here is the first vertical asymptote, and then here's the second. Next, let's explore whether we can expect a horizontal asymptote. For this, we're going to compare the degree of the numerator, which in this case is 1, to the degree of the denominator, which is 2. Because the degree of the numerator is smaller, we will have a horizontal asymptote at the line y equals 0, which is the x-axis. So I will add that as a dashed green line as well to show that that is yet another asymptote. So we see that there are 6 regions that are created in our graph, 3 above the x-axis and 3 below the x-axis. This is a more complicated graph because as opposed to the previous examples where we expect 2 branches, we really could have a combination of branches and some curves, given that we have 6 regions. I want to make one note here about an important difference between horizontal and vertical asymptotes. Vertical asymptotes are strict, meaning the graph can never touch or cross over vertical asymptotes. However, horizontal asymptotes are a little bit more permissive, especially in cases like this, where we have various regions. Horizontal asymptotes may repel the graph in some of these regions, but then be more permissive and allow the graph to cross or touch the horizontal asymptote in other places. And that's exactly what will happen here. So just keep that in mind. Vertical asymptotes are very strict. Horizontal asymptotes may repel the graph in some places, but not in others. So it's more permissive. Let's look at any possible x-intercepts. So there we would have to set y equal to 0 and solve for x. So we see here that if I set y equal to 0, remember f of x is just another synonym for y. Essentially, we would have to let the numerator equal 0, which would give us x equals positive 1. So we have one x-intercept at the point 1, 0. For y-intercepts, we would set x equal to 0. And so by setting x equal to 0, we have y equals 0 minus 1 in the numerator, then 0 minus 4 times 0 plus 1 in the denominator. So we get negative 1 in the numerator, and then we get a negative 4 in the denominator, so we get positive 1/4. So we have one y-intercept at the point 0, 1/4. In terms of the domain, we see that there are 2 values for x that have to be excluded. X cannot be 4 and x cannot be negative 1. This is where the vertical asymptotes occur. So we have to skip over 2 values. So in interval notation, we will write the domain as going from negative infinity up to, but not including negative 1, and then the interval from negative 1 to 4, neither of those values included, and finally everything to the right of positive 4, so from 4 to infinity. Now, in order to actually find the shape of this more complicated graph, We can start with the x and the y intercept, but that certainly is not going to be enough. So we'll have to find additional ordered pairs. For now, let's go ahead and add the x-intercept at 1, 0, and the y-intercept at 0, 1/4. So again, this is not nearly enough for us to get an idea of what the different parts of the graph will look like. So I will prepare a table of values that will give me some additional ordered pairs. And I'm going to do that down here below. Let me just create a little bit more space. So in order to choose ordered pairs that are helpful, that make sense, first I want to find additional x values between -1 and +4 to kind of find out what's happening in that middle slice. So I'm going to choose values like, let's say, for instance, 2 and 3 for x. And let's see what happens at those values. So when x is 2, y is equal to, the numerator would be 2 minus 1, which is 1, over 2 squared minus 3 times 2 minus 4. So that is -6, I believe. And so we get -1/6. So 2, -1/6 would be right about there. When x is 3, the numerator is 3 minus 1, or 2. In the denominator, we have 3 squared, which is 9. 9 minus 3 times 3, so that's 9 minus 9, which is 0. So we just get -4. So we get -1/2. So 3, -1/2. Now, I do see kind of this decreasing trend, but I still don't feel really confident that I know what the middle part of this graph is going to look like. I do see that it's crossing over the x-axis. So what I want to do is get super close to x equals -1. So I'm going to go to -0.9. So that's just to the right of that vertical asymptote. And when x is equal to -0.9, I've kind of worked this out in advance, y is approximately 3.9, so really close to 4. So we see here that I'm going to get really close to x equals -1, but not quite get there. And then the y coordinate jumps up to close to 4. Now I want to get close to x equals +4. So I'm going to get super close to it and go to x equals 3.9. And again, I've worked this out previously, and I find that the y value is approximately -5.9, or approximately -6. So as I get really close to 4, then I get a really low y value. And now I get the sense that there's a curve in this middle part of the graph. And so I can predict that the graph will come close to that left vertical asymptote and then come close to that right vertical asymptote. And so it'll look something like this. Now, let's take a look at what happens in those left two regions and in those right two regions. So I'm going to pick some additional x values that will give me points to plot. So I want to pick x values that are less than -1, and I've picked some out in advance. So I've picked out -6 and -10. And let's see, when x is -6, I get approximately, I got -7/50. So that's very, very, very small. And let's go ahead and plot that. -6 for x, and then -7/50 is not that much lower than the x-axis would be. I also chose x equals -10, and I got a very small number as well. I got approximately -0.1. So when x is negative 10, again, I get a very, very small value. So I'm predicting that there's going to be a branch kind of in this left bottom corner, but to really feel confident that it is a branch, I want to get close to that vertical asymptote. So I'm going to choose a value like negative 1.1, which is just to the left of that vertical asymptote. And again, I've worked this out in advance. That gives me an approximate value of negative 4.1 for y. So indeed, if I go just to the left of x equals negative 1, then I get all the way down here past negative 4 for y. So these 3 points, I think, give me enough confidence to predict that I will have a branch that is in this bottom left-hand corner that is going to get really close to that vertical asymptote, but not touch or cross it. Finally, I want to find out what the graph is doing in the right two regions. So I'm going to pick some x values that will help me predict what kind of branching action is present. So I'm going to pick values like positive 6 and positive 10 for x. When x equals 6, I get a y value of approximately 0.4. So that puts me right about here. And when x equals positive 10, I get a y value of approximately 0.1. So I see that I can predict that as I go to the right, that graph is going to start getting closer and closer to that horizontal asymptote. But to feel really secure that what I have is a branch, I want to pick an x value that's really close to that vertical asymptote at x equals 4. So I'm going to go just to the right of x equals 4 to x equals 4.1, and I get an approximate y coordinate of 6.1. So what that tells me is if I go just to the right of that vertical asymptote, I climb all the way up here past y equals 6. So again, these 3 points now give me some confidence that I will see a branch in this region, and this graph is going to keep approaching the x-axis as we move to the right. So this graph was quite complicated to pull together. Don't get too frustrated if you're not getting a good sense of what the graph looks like right away for these more complex problems. It really is just a matter of starting out with the basics, the x and the y intercepts, the vertical and horizontal asymptotes, looking at the regions, and then really just choosing x values that will give you enough plotted points for you to predict what the rest of the graph would look like.